Today I'm going to talk about a multi-thread prime number generator. So I'm going to show my homework 2 for parallel algorithm, a multi-thread prime number generator using p threads. So to do this, the goal of this assignment is to create a program that launches 100 threads simultaneously, and each thread will generate random numbers and test them for primality using the brute force algorithm. At the end, we collect result from all threads to see which one found the prime numbers. So to do this, I will go through the implementation of the code, how to compile it and run it and show the results for the code. So to do this, first I want to go to the code. So this is our basic code. First, look at the configuration of this code. I have defined number of threads as 100, and the maximum tries is 10, which means that each thread will attempt at least 10 times before giving up to find the prime number. And the max value limits our random number range. I'm using here very large number, but it's kept to keep execution time reasonable. And I created the thread result structure to each thread's data. It contains the thread ID, and if there is a prime number found. If no prime number is found, it will store 0 here. And now the heart of this algorithm is the isPrime function. This uses an optimized brute force approach to check if a number is prime or not. First, we handle the base cases. Number less than or equal to 1 are not prime. 2 and 3 are prime, so we return 1 immediately. And then we check the number is divisible by 2 or 3. If it is not prime. Here is the optimization. Like instead of checking every number, we only test divisors of the form 6k plus minus 1 and up to the square root of x. This actually significantly reduces number of checks we need to perform. Like after 2 3, the next potential divisors may be 5 7 11 or 13. And if we find any divisor, we return 0. If we make it through the loop without finding divisors, the number is prime and we return to 1. So next is our thread function. This is what each of our 100 thread will execute independently. It takes void pointers as argument, which we cast to our thread result structure. This is how we pass data to and from each thread, and each thread runs a loop up to max tries, that is 10 attempts. In each iteration, we generate random numbers using the ran modulo max value, and we immediately test if the number is prime using our isPrime function. If it is, we store it in the result structure and exit the thread using pthread exit. And if we exhaust all 10 tries without finding a prime, we set the prime value to 0 and exit. This signals that this thread didn't find any prime number after maximum tries. Now in the main function, where everything comes together, like we declare two arrays. on for thread handles and on for the results, but have number of thread elements that is always 100. And we seed the random number generator once using the current time. Here the where we create all our threads. For each thread, actually I initialize its result structure, setting thread ID prime to 0, and then we call the p thread create, and for each thread we initialize its result structure, setting thread ID and prime number to 0, and then we call the p thread create, and that creates new thread that will execute or generate prime function. We pass a pointer to the thread result structure. If thread creation fails, we print an error and exit. This is important for this code, and after creating all threads we need to wait for them to finish. That's what pthread join does. It blocks until the specified thread is actually completes its operation, and this is crucial because we don't want to print results before thread are done working. And also once a thread has joined, I check this its result. If the prime value is non-zero, that thread found a prime and we print it. Otherwise we print that no prime was found by the thread. So in this we use the 100 threads to running in parallel. So now I'm going to compile the code and run the code. So to compile the code as per the assignment instruction, we need to use the pthread flag for thread support, wall to enable wall warnings, and 03 for maximum optimization. So now it's compiled. So now I'm going to run this code. So this is our result. Like the number of prime is not found by the thread number 99, 98, and there is a prime number found by thread number 95. And the prime number is 477054421. I verified this prime number through the Wolfram Alpha. They are all mathematically correct, I found, as per my I didn't check all the prime numbers, but randomly I checked few prime numbers and get all things are good. And thank you for watching this video.